Let's consider here one cantilever beam of AB and BC part. On BC part, we are UDL of load W. We have to find out deflection at the point B, deflection at point C, slope at point B, and the slope at point C. So for this purpose, first of all, we have to find out the reaction at this point. So this reaction is same as W into L, and the moment of this one is W into L into this distance. So that will be equals to anti-clockwise is WL, W into L and 3 by 2L. So this is 3 by 2 WL square by 2. So here we have a shear force diagram. This load is acting upward. So this is upward. It's constant from this point to this point, and from this point it will be equals to 0. So this load is same as WL. This length is L. This length equals to L. This one is your moment, which is a negative moment. So you have to come downward. So it is 3 by 2 WL square by 2. Area of this figure is WL square. This quantity is minus. So minus 3 by 2 WL square plus WL square will be equals to, is a rectangle, is a triangle. So this quantity will be minus of WL square. And the area of this figure is same as WL by 2. So that is the same area. So this will close down. This is a triangle. So it's a parabola, will be of negative parabola. Slope is positive parabola, but the slope is decreasing. So is that parabola will be like this. So we have this point is A. So whatever the area is formed under BMD diagram is consist of standard three area. One is rectangle, one is triangle, and one is cubic curve. This height is WL square by 2. So we divide by EI. That become curvature diagram. So this height will be equals to what? This is WL square by 2. So is this height will be WL square divided by EI. This quantity plus this quantity is equal to 3 by 2 WL square by 2. So we can find out area A1, area A2, area A3 also. Now first of all, we'll try to find out the slope at point B. Whenever you have to find out the slope at B, so do you have BMD at this point? Yes. Do you have BMD at this point? Yes. So our curvature diagram will start from this. I will get this line first up to this point, and then I have different slope for this line because the elasticity of this area is different and this area is different. So I will continue the same figure. So exactly at this point I will start with another curve like this. So this deflection is what? YB, and this deflection is what? YC. So first of all we will calculate theta B. If the slope at point A is 0, to find the slope at B we will take the advantage of A. So we write theta B minus theta A. So it is the area of the curvature diagram between A and B. That is the area of 1 plus area 2. So this one is area 1 plus area 2. Out of this, area 1 is rectangle and area 2 is triangle. Area of this rectangle is WL square multiplied by L divided by twice EI. So this is WL cube divided by twice EI. This one is WL square by EI, this one is L, this is WL square, WL cube by EI, and this one is triangle. So is equal to WL cube divided by twice EI. But what is the slope at point A? Is 0. So do you have the value of theta B is equals to WL cube divided by EI. Second one, if you want to find out the slope at C, again we should take the slope at A because the slope at A equal to what? 0. This time, do you have area A1 plus area A2 plus area A3? So out of that, we already find out the area of A1 and A2. We have to only find out the area at point 3. So first to answer is W, L cube divided by EI. Degree of this one is 1, degree of this one is 2, and this one is inside the triangle. So is it equal to 1 by 3. Height of this one is WL square by twice EI. L is the length, so this is W, L cube by 2 times EI. This is 1 by 6, 1 by 6, and this is 7 by 6, W, L cube divided by EI. We will now go for YB, that is YB. So for YB, we have a slope at A equal to 0. To find out the value of YB, you have to measure the distance from point B, opposite of A. So what is YB? YB is equals to, you have to measure all the distance, that is area 1 and this one. So we will write this one as A1 multiplied by x1 plus A2 multiplied by x2. So what is the area of this figure? We have to measure all distance from B. So A1 is same as WL cube by twice EI. What is the distance of centroid from this point to this point? So this is my x1, L by 2. What is the area of this figure? Is WL cube by 2 EI. And you have to measure the distance from this point. Is 2 by 3. Okay, I will go for the last term. That equal to what? YC. To find out YC, I have to first find out one point whose slope is 0. That is A. Opposite of this point will be equal to what? C. So all the distance are measured with respect to C. So we have a new definition of x1 and all those things. So first of all, A1 multiplied by x1 plus A2 multiplied by x2 plus A3 multiplied by x3. Let me have a clear idea about x3. This one is point. This is centroid of figure number 1. But this time the distance from this point. So this distance will be called as x1. Is the distance x1 is equal to L plus L by 2. This is L by 2. This one is L. This is 3 by 2. Next I will mark you x2. x2 is for this figure. For this figure is here. It is measured from this point. This distance already equals to what? L plus from here to here. This distance is 2 by 3. 2 by 3 L. So this distance is 5 by 3 L. And lastly, I have to measure the distance of this centroid. So this centroid is here. Its a degree equals to what? 2. So this distance will be equals to x3. So this x3 was calculated using a formula n plus 1 upon n into L. N is 2. So this one is 3 by 4 multiplied by L. Then is it the area A1? A1. This is the area A2. And is it the area equal to A3? So you have to substitute all this value and you have to solve it. So this one is A1, this one is x1, this one is A2, this one is x2, A3 and x3. WL to the power 4 divided by EI, 41 by 24.